Okay, so this is for those of you that are at home. We finished off yesterday's notes with these two problems, and then today we did this example. So we're going to go through and identify the number of inputs, assign variable names in the condition for 0s and 1. We'll make a truth table, and I'm even going to go ahead and do the expression with the minterms. Okay, so basically just starting to introduce you in practice, kind of taking a word problem and pulling out of that word problem what are the inputs. So if we read this, it says, Ms. Markovich keeps her final exams in her office. For security reasons, she would like you to design an alarm system for the office. Her office has a window and a door that are both equipped with sensors that output a 1 when they are secured. Okay, so they'll output a 0 when they're unsecured or open. When the alarm system is turned on with a key, the siren should sound if either the window or door is unsecured, which is going to be a 0. So we have a window, we have a door, both have alarms, and we have a key that can arm the system, right? So I'm going to go ahead and say that we have a key. I'm going to call it K, and they didn't tell me in here what to define that, so I'm going to define K to be a 1 when, let's say, it's, I'll say it's armed, when the security is armed, and we'll say that K is 0 when the alarm is unarmed. Okay, and then we have the window, which will be W. They told us that W will equal 1 when it is secured, and W will equal 0 when it's unsecured. And then same for the door. We'll call D. D is equal to 1 or 0. 1 is secured, and 0 is unsecured. So we have 3 inputs. We have K, W, and D. And we have the alarm as the output. All right, with 3 inputs, the number of combinations that are possible is represented by counting in binary from 0, 0, 0, all the way until we get to all ones, 1, 1, 1. So 3 inputs, that's going to be 2 to the 3rd combinations, which is 8. All right, so we're going to practice counting in binary here. All right, so we're going to start with 0, 0, 0, and then that's 0, which then 0, 0, 1 is 1. So the nice thing about counting in binary here is that counting in binary finds and lists out all the different combinations that you could have, with K, W, and D having only 2 possible values. So we're at 2. Now we're going to go to 3, and I've got to the biggest number I can get to with using these 2 place values, so now I need to go to the K place value, which is going to be my 4. So 4, no 2s, no 1s, and then 5 is a 4 and a 1, 6 is a 4 and a 2, and then 7 is a 4, a 2, and a 1. So we've gone from 0, 0, 0 to 1, 1, 1. Now, filling out our truth table, we need to list when the alarm should sound. The siren should sound if either the window or door, so either implies or, is unsecured, which is a 0. So if the window is 0 or the door is 0, or even both, it would sound, but only if the key has actually armed the system, right? We said that 0 is unarmed, so if the alarm has not been armed, it's kind of deactivated, then all of these will be 0s because the key is not in the position to arm the system. So I'm saying the key is an actual input, and I don't know if that was the example's intent, but that's how we're going to do it. Okay, so all of these represent the key is in the position to arm our system. So now, if either the window or the door is unsecured, the alarm will sound. So right here we have 0, windows unsecured, the alarm should sound. Just so happens the door is also unsecured, and it should have sounded. Okay, here we have the door secure, but the window's not, the alarm should sound. Here we have a secure window, but an unsecured door, alarm should sound. And here we have a secured window and a secured door, the alarm should not sound. Okay, so we ended up with, switch colors, 3 different combinations. Okay, these are the combinations that yielded an output of the alarm sounding. And then these combinations are going to be recorded as a Minturn expression. So it's a combination of the key, the window, and the door. The key is 1, so I'm going to leave that as plain old K. Window was unsecured or 0, so I'm going to put a line over the W for not W. And then door as well, so not door. And then the next one is going to be, they're all KWD, but it's a matter of where we put the bars. So over the W for the 0, and then here over the D. Okay, so if we wanted to write the expression for when the alarm should sound, okay, so the alarm should sound when I have K, not W, not D, that combination, or we use a plus to represent or, K, not W, D, or K, W, not D. All right, now, for those of you working from home, you move to the next activity, and I had the students complete number 1, number 3, and number 5. They did not have to do 2 or 4 for the sake, I mean, you can, some did, you can do them pretty fast. You want to go back to yesterday's notes just to practice and see the examples of taking the truth table and writing the expression. It's basically what I just did right here, okay? So these are to try on your own. This is what you would want to take a picture of and submit to me by email. If you flip the page, these are practicing going from the Minturns to the truth table, and that's the second thing we did yesterday in yesterday's notes. I asked them to only do number 3. Now, as they did this, though, I did get some questions, and so I can go back to number 2 real quick, and the questions really were surrounding around like this one and this one. Okay, now first off, I see R's, I see S's, I see T's. I don't see any other letters other than R's, S's, and T's, right? So I know my inputs are R's, S's, and T's, and then the output is the F2. So with 3 inputs, we're going to count from 0, 0, 0 to 1, 1, 1. Okay. And then completing the truth table was understanding where these expressions led us to put 1s. Okay, so first off, this is not R, so it'd be a 0. S, not T, that'd be 0, 1, 0. So I'd be looking for 0, 1, 0, which is right here, and I would put a 1 there. Okay, this one here is not R, which is 0, not S, which is 0, and not T, which is 0. So 0, 0, 0 would give me a 1. That one's right there. Another good color. All right, now this one, R is 1. It's not S, which is 0. And then T, there's no T in the expression, right? So that is a don't care. I don't care what T is, if it's T or not T. So I'm looking for 1, 0, and not even looking in the third column. So I see a 1, 0 right here and right here. So both of these fit R, not S. So I'm going to put a 1 in both of those. Now, that is really 1, 0, 0 and 1, 0, 1. So we could also write that as R, not S, not T, and R, not S, T. So this is planting a seed right now, kind of foreshadowing that later on you're going to learn a way that you can take an expression of minterms and simplify it and be able to acknowledge multiple minterms that should be a true with a simpler expression. Instead of having to have the sum of these two expressions, that covered both of them. Okay, we're not going to do that yet, but just know that you're later going to be able to take a more complicated expression and simplify it down to have less things, by kind of combining one expression might cover a couple of these. Okay? So that's how I covered that one. I'll do the ST, but that was the question on this one, was how to cover that AC. So here, there's R is first, so I don't care about R. S is 1, T is 1. So it's a don't care 1, 1. So I'm looking for 1, 1, like right here. I guess I already used that color. What's a color I didn't use yet? Maybe purple here. So don't care 1, 1. So I see that here. And then I also see it down here, 1, 1. Then you go back and fill in all of the rest with zeros. Okay? So you guys are doing number 3. And then basically putting it all together. Now this, you just read it, kind of tells you, hey, this is we are revisiting a circuit we already did in Unit 1 or talked about. But they note that this is slightly different, and they're giving you right now very explicit instructions in terms of what's 0, what's 1. And they're telling you here, your new car has an audio alarm that buzzes whenever blank. Read that sentence. Tells you when, right, in words, you should be getting ones. So this sentence here should help you figure that out. This here tells you if it's door open or door closed, right? Interprets what are the zeros and ones. So with that sentence and these definitions, you should be able to find your ones here. From there, you're going to write the expression with the sum of products. Okay, Minturns, this is what it's going to look something like that, right? But with D, K, and S. And that was the assignment for today. Okay, so we did little notes, and then they tried to complete those in class. And I think everybody, actually I know pretty much everybody got it done in class. I then had a few extra minutes and gave the students a little foreshadow into the future. And I did it with number 1 because they had already done it. Here I'm going to do it with you for number 2. And if you can kind of pause, make a note at the time. We're at the 12.5 minute mark basically. And you can come back to this in a second after you've completed these. But I wanted them to start to understand what this might be doing. And also a couple students flipped the books and kind of saw some things that are coming up. And so I told them, hey, here's the real deal, right? Like, so my Minturns right here, I've got a 1, that's X, Y. And then here I have, actually, you know what? I'm going to do it with this one because it's going to be a little simpler for the little bit of space I have here. There's 3 1s. There's only 2 1s here. It's a space issue. So let's see. This is not M, not N, and this is M, N. Okay, and so I showed them that basically we're figuring out how to write circuits, how to design circuits through all this work. So not M, not N is really and. It's not M and not N. Both that combination, right? This is a combination that led to 1. So in a circuitry, if I had a signal, a wire that was carrying M, I want to create the combination of not M and not N. So I would run M through an inverter, and then I would have not M. Okay? And then maybe I'll just use, I guess, a different color. N. If I want to create not N, I would run N through an inverter, and that would create not N. Okay, now to get the product of M and N, that's where I need to run those two through an AND gate, which looks like this. So I'm going to have not M go into the AND gate. I'm going to have not N go into the AND gate, and what comes out, okay, is not M and not N. Okay, so that was a combination that should give me a 1. The other combination was MN, so I also want to create that. So to create M and N, I'll grab this brown, kind of bring it over here. That's my M signal. I'm grabbing it in front of the inverter. And then N is there. Okay. And then I'm going to run both of those through an AND gate as well. Okay, and then what comes out there is now M and N, the combination of M and N. Now, this or this, either of those combinations yielded a 1. So either of these are good. So now we're going to say I want either or. So I'm going to use the OR gate to bring these two in, and that gives me not M, not N, or M and N. And so this process of taking word problem to truth table to Minturn expressions to a sum of product statement is going to lead us into the design of our circuits. And I hope that plants a seed and just makes sense that you can, I realized that when I was a student taking this class, I didn't have the advantage of seeing what was coming up. And when you can see what's coming up, it helps you value what you're doing currently. So you're not just thinking, why are we doing these little tables and trying to write these expressions? You don't see the connection yet. So I'm trying to foreshadow the connection of where we're going and how all of this is going to get used. So that was it for the day. I hope you guys have a fabulous weekend at home. It's nice outside. I'm sorry you're not here with us. Get outside, get some fresh air, and I hope you guys are doing great. Email me with any questions at any time, and I'll do my best to respond to you when I get a minute at home. Pull my laptop out and communicate with you guys. So again, take care. See you soon.